Hello there. Welcome to Practice Math with this video. In today's video, we're going to master the cousins of the sine rule. And what is that? Yes, this is none other than the cosine rule. What is cosine rule? Why is it we have to learn the cosine rule? On the screen, you will see a triangle. I'm going to label the angle as uppercase A, this as uppercase B, and this one as uppercase C. And the side that is opposite the angle, I'm going to label it as lowercase a, lowercase b, and lowercase c. Supposing I'm given the dimensions for all the three sides. Let's have an example. Supposing I'm given this to be 10 centimeter, this one 8 centimeter, and this is equals to 9 centimeter. And I'm asked to find angle A. Find angle A. Find angle A. Let's see if we can actually use the sine rule to solve this problem. So what is the formula for the sine rule? Yes, it goes like this. The ratio for sine A over the side A will be equals to the ratio for sine B over the side B, or equals to sine C over C. So I'm going to use this first. Let's look at what we're given. All right, A is not given, so let's cross it out. Angle B is not given, let's cross it out. But the sides A is given and the sides B is given. So if you look at this equation, we have one equation with two unknowns. So surely we cannot use sine rule here. Supposing I used this ratio, sine A over A equals to sine C over C. All right, I'm not given the angle A, so cross it out. I'm not given the angle C, cross it out. So again, we end up having an equation with two unknowns. So we are trapped. And therefore, we need to learn a new rule, and this rule is called the cosine rule. So what exactly is cosine rule? So using this diagram, cosine rule works this way. If I want to find the values for side A, so this is equals to A squared is equals to B squared plus C squared minus 2BC cosine angle A. And if I want to find the value for side B, this is equals to A squared plus C squared minus 2AC cosine angle B. All right, so that's one way to remember it. And if you're finding the side A, can you see the connections there? You're finding B. If you're finding C. All right. And where do we get this two value? It's actually from here. Okay. Likewise, this one is from here. And this is from here. Okay. So that is cosine rule. All right. So I'm going to use this, right, to find angle A. So to find angle A, I would have to use the first one. So I'm going to erase the second and the third one. All right, so I'm going to fill in the values for A, which is given to be 10. So this is 10 squared. B is 8 squared. C is 9. So minus 2 times 8 times 9 times cosine angle A. And if you use the calculator, this will give you 100. This will give you 145 minus 2 times 8 times 9. That gives you 144 cosine A. Right, so I'm going to make this the subject. So I need to get rid of my 145. So to get rid of 145, I have to minus 145 on both sides. So I take away 145 on both sides. And I'll end up having negative 144 cosine A on the left. Okay, I'm going to continue. So 100 minus 145 will give you negative 45. So I have negative 45 equals negative 144 cosine angle A. So to find cosine A, I divide by negative 144 on both sides. And that gives me cosine A equals to 5/16. And to find angle A, I just need to cosine inverse 5/16. And that gives you 71.8 degree expressed to 1 decimal place. Right. But if you're not keen, right, to go through all these steps, finding the angle, because basically this formula is mainly for finding sides. That means you're given angle A, you're given side B, side C, you just need to find the side A. So if you want to find the angle, but you have given all the 3 sides, then it will be good to remember another form of formulas, which I'm going to show you at the next slide. All right, let's summarize the formula. This cosine rule can be applied to a cube angle triangle, obtuse angle triangle, and even a right angle triangle. Let's start off by labeling all the appropriate angles and the sides. So this is angle A, and the sides that's opposite angle A will be labeled as lowercase a. So all the angles are labeled using uppercase, and all the sides are labeled using lowercase. So this is something you have to follow. Right, so if you're finding the value for the side A, so A squared is equals to B squared plus C squared minus 2BC cosine angle A. If you're finding side B, so it's B squared equals to A squared plus C squared minus 2AC cosine angle B. If you're finding side C, it's A squared plus B squared minus 2AB cosine angle C. Right, so this is for finding sides. If you're finding angles, then supposing you want to find angle A, so cosine A will be equals to B squared plus C squared minus A squared over 2BC. If you're finding angle B, so cosine B is A squared plus, yeah, so of course, if you're finding, then you have to cosine inverse it. Yeah, so from there, your angle A will be cosine inverse B squared plus C squared minus A squared over 2BC. Right, but it's easier to remember it in terms of cosine A and cosine B, cosine C, after which you have after which you have a value, and then you just cosine inverse the value. Okay, so if you're finding angle B, so that will be A squared plus C squared minus B squared over 2AC. If you're finding angle C, that will be A squared plus B squared minus C squared over 2AB. So it's not difficult to remember if you look at the pattern. All right, if finding angle A, can you see that you take away this one here? And the denominator is just the first two letters here. So once you understand the patterns, how the formula is formed, it's pretty easy to remember it. All right, let's practice doing these questions. So we're given the triangle ABC, and let's label the angles and all the sides. Right, so you're given A, that is A, which is 5 centimeter, given the side B, 7 centimeter. So B is opposite the angle B, and angle C is 60 degrees. So we asked to find side C. All right, so let's write down the formula. So to find C, the formula is C squared equals to, so there are only three sides, right? So the all label is ABC. So you're done with C already, then you will be equals to A squared plus B squared minus 2AB cosine angle C. Okay, so let's fill in all the information that are given. A is 5, B is 7, angle C is 60 degrees. And you can just use your calculator to work this out. So 5 squared plus 7 squared, so that's 25 plus 49. That gives you 74. This one you can just work it out also. 2 times 5 times 7 times cosine 60. So 74 minus 35 will give you 39. So C will be square root of 39. Okay, because C is a positive value, right? So we only take the positive value for C. So square root 39 will be 6.24 centimeter expressed as three significant figure. Right, so in this video, I'm providing the solutions to exercise 6D. Right, so if you just want to learn how to use the cosine rule, you can just stop here. Otherwise, you can continue to look at how we can solve the problem sums from exercise 6D. All right, in the previous slide, we have learned how to find the values of an unknown side using the cosine rule. So in this question 12, all right, we are asked to find the value of the unknown angle instead. So on the diagram, we're given triangle ACD, ADB, and of course the big triangle ACB. And in part I, we asked to find angle ADB. So we asked to find this angle. So we see that you can't possibly use this triangle ADB because there are a lot of unknown. All right, we're only given 50 degrees and the opposite side is 2 cm. And the rest of the information is not given. So we can't use ADB. However, we can use the triangle that is beside it, which is your triangle ADC. And why is that so? Because you're given all the three sides in this triangle. And therefore, we can use the cosine rule to find angle ADC. And with ADC known, we can just use 180 degrees to minus that to get ADB. Right. Okay, so our job now is to find this angle. Okay, so let's write down the formula. You can just remember any formula. as in like you can just remember cosine A or cosine B or cosine C, doesn't matter. So let's say you remember how to find cosine A. So cosine A is equals to B squared plus C squared minus A squared over 2BC. Right, so if you were to recall, okay, this is your angle A, right? So the B and the C are the one that is beside, you know, it forms a victory sign or a caret sign like that. And of course, the side that's opposite angle A, it's your lowercase a lah. Okay, right. Because a lot of times the diagram given to you, they don't use the letters that's been used in the formula. Like in this case here, you're given angle A, but this is angle D, and that is C. You're not given ABC. Yeah, you're given ABC here, but of course you can't use ABC here because again, not enough information. So you can only use angle ADC first. That is the only triangle that gives you a lot of information. Okay, so you must know what to substitute in for your side B, side C, side A, angle A. Right. Okay. Right, so this is what we're going to do. We're going to find angle ADC using cosine rule. So in triangle ADC, we're going to replace your angle A with ADC. Okay, and then your B would be 3.5. This is your value for B. C, this is the value for C. Okay, minus, of course, the opposite side, it's your 4.5 squared. All right, you get negative 2/7. So cosine inverse that will gives you angle ADC. And of course, you're not finding ADC, you're finding ADB. So ADB will be 180 degrees minus 106.60. That gives you 73.4 degree as far as the one decimal place. Right, we're going to solve the part 2. So part 2 of the questions, we're asked to find the shortest distance from A to CB. We're going to let the shortest distance be H. And the shortest distance will form a 90 degrees with the sides BC. So this will be 90 degrees. Okay, this will also be 90. Right, so we can find the area of triangle ADC using half AB sine C. Right, half AB sine C. So we have already found angle ADC early on. We found this angle early on to be 106.60. We're going to use the angle. So the two sides that form a victory sign, this will be the two sides, right? So you can let 3.5 be A, and then B be 2 cm, and of course the angle C will be this angle here, which is your 106.60. Okay, so this is one way of finding triangle ADC, half AB sine C. If you've forgotten how to do that, please refer to the earliest video. Okay, I think it's assignment 6A or 6B, one of the earliest video. So another way of finding the area of a triangle ADC will be using half base times height, because we already let the perpendicular height be h. So using half base times height, that will be half times 3.5 times h. Which gives you 1.75 h. And of course, these two areas, they will have to equate each other because we're referring to finding the area of the same triangle. We're just using two different methods, but the value that we get will be the same. So therefore, 1.75 h should be equals to 3.354. And we can divide by 1.75 on both sides to find h to be 1.92 cm. So that will be the shortest distance. Right, so let's look at part 3. Part 3, we asked to find the length of BD. Okay, so to find the length of BD, I think the easiest way, to do were to be use triangle ABE, because this is a right angle triangle, right? We can use Torcaso to find BE. Then use triangle AED to find DE using Torcaso again, and add these two values up. You will get the value for BD. So in triangle ADE, okay, we already found the values for angle ADE early on, right? So we can use that. So we can use tangent, because we found the height to be 1.9166, so we can use tangent, right? So DE will be 0.5714, and then we can use triangle AEB, right? And we basically just add these two values together and you'll get the BD. Right, in this second last questions, we are given a trapezium ABCD. All right, we're given AB is parallel to DC, AB is 4.5, BC is 5, CD is 7.5, and AD is 6. Okay, we don't have to draw a very accurate diagram, but basically it cannot be too inaccurate. Right, so we all know that the properties of a trapezium is such that it has one pair of opposite parallel sides, one pair only. Right, so let's have AB first. So AB it's 4.5 cm. And BC is 5 cm. Okay, 5 cm. So 5 cm must be longer, therefore slightly longer than 4.5. Even though we say it don't have to be a very accurate, but can't be too inaccurate also. CD it's 7.5, so it has to be much longer. AD it's 6 centimeter. Okay, mix up, yeah, fine. Okay, so the diagram is a bit fine. Okay, so we are given a point X lies on CD such that BX is parallel to AD. Oh, okay, so we have, right, X here, and these two are parallel, and this one are parallel. Oh, so from the diagram we have just drawn, what do you think is the name given to the quad ABXD? Yes, ABXD is a parallelogram. Okay, if it's a parallelogram, means opposite sides are parallel and equal, which means that your AB is equals to DX equals to 4.5 centimeter. Right, your AD is equals to BX equals to 6 centimeter. So then we'll be able to find XC to be 7.5 minus 4.5. Because XC is DC minus DX. And that gives you 3 centimeter. So this guy is 3 centimeter, this guy is 6 centimeter. And we are to find angle BCX. Find this angle here. Okay, very good. So we're going to use this triangle. And we can basically use cosine rule to find angle BCX, right? So the angle, the sides as opposite angle BCX will be 6. And your 5 and 3 are the one that form the B3 sign. Okay, so let's write down the formula to find the angle. Right, so if you remember, cosine A is equals to B squared plus C squared minus 2BC. Sorry, wrong. B squared plus C squared minus A squared over 2BC. Okay, let's fill in the actual name for angle A. So the actual name for angle A is BCX. So cosine angle BCX. Then you can let this be B. This is your C. And of course, your A must be opposite the angle BCX, which is your 6. Over 2 times 5 times 3. So angle BCX will be cosine inverse that value there, which I think is negative 2 over 15. Oh no, it's not. It's negative 1 over 15. So cosine inverse that. And that gives you 93.823 or 93.8 degrees for angle expressed to 1 decimal place. So that is angle BCX. Okay, the next thing is to find the length of BD. Okay, so BD, right. Okay, so we're going to use triangle BCD. Why use triangle BCD? Because we've found angle BCX. So we're going to use triangle BCD. So in triangle BCD, okay, we're going to use cosine rule. Right, so BD squared. Okay, let's write down the formula. So formula for cosine rule will be A squared equals to B squared plus C squared minus 2BC cosine angle A. Right, so we're going to replace the actual name. The actual name is BD instead of A. So this is BD squared. Then the other two sides will be DC and BC, right? DC and BC. So it's 7.5 squared plus 5 squared minus 2 times 7.5. Oh my goodness, running out of space. Your angle A is your BCX, which is also BCD lah, and that is 93.823. Okay, so you can use your calculator to work it out. Okay, it's a bit messy here. 7.5 squared plus 5 squared. 81.25 minus 2 times 7.5 times 5 times cosine 93.823. Negative 5. So that gives you 86.25. So therefore, BD will be the square root of this. And since BD is a positive value, we only take positive value, which is 9.29 centimeter. Okay. Right, let's look at the last questions. In these last questions, we're given triangle APQ, also given triangle ABC. Right, we asked to find the length of PQ. Okay, so PQ belongs to this triangle APQ. And clearly, there's nothing much we can do using triangle APQ. Okay, because you're just given two sides, 5 cm, 6 cm, and no angles at all. All right. But we can actually use the bigger triangle ABC, because your triangle ABC, you're given 14 cm. You basically add this together to find the length of AB. You add this together to find the length of AC. So from there, we can find angle BAC using cosine rule. Okay, so let's write down the formula. So cosine A is equals to B squared plus C squared minus A squared over 2BC. So if you're finding angle BAC, you're finding this angle here, that will be your angle A, right? So you're going to replace your angle A with BAC. Then of course the other two sides will be this here, which is 8 centimeter, and this one here, which is 13 centimeter. Right, so we can just let B be 8 or 13, and then C will be the other one. So then, of course, your A will be 14. A is the one that's opposite your angle BAC. Okay, so this is how we can use the formula. Right. So this is how you look like. Okay. So the value for AB will be 8. AC will be 13. BC is 14. So let's substitute in all the values. All right. And angle BAC will be 79.75. So once we know the values of BAC, we can now zero into this triangle to find the length BQ. Okay, so A squared is equals to B squared plus C squared minus 2BC cosine angle A. So that's replace your side A with PQ. Then B can be 5, C can be 6. And of course, the angle we found out earlier on to be 79.75. Okay, so let's do it now. All right, so you will get, again, PQ, it's a positive value. So PQ being more than 0, therefore we only take the positive value. All right, so that's all. Hopefully this video has taught you one thing or another on how to use cosine rule to solve more problem sums.